Hello students, in the last lecture we discussed the manufacture of sulfuric acid. We have started the discussion of contact process. Under that we have seen what is the raw material. Then we discussed the description of plant, and then we started the description of process. In that first step is sulfur or pyrite burners, which convert sulfur to sulfur dioxide using oxygen. Okay, then these are further passed through mm, purifying unit that we discussed here. And this purifying unit, that is first four chambers as we have seen here. They are carrying out this purifying job, and how it is get done, that we discussed in last lecture. And at the end of purifying unit there is a testing box. This testing box check the quality or purity of the output of the pyrite burner, whether it is free from water, free from arsenic, free from dust. So it should contain only a sulfur dioxide gas. Okay, and after testing by testing box, we'll move further to the next very important process, that is contact converter. This contact converter, the basic unit is contact tower that were seen in the previous slide. In this contact tower, sulfur dioxide is converted to oxygen using catalyst vanadium pentoxide. Okay, it is converted to sulfur trioxide. So this process is carried out at 595 degrees Celsius, and lot of energy is evolved. This reaction is exothermic. So if temperature is not controlled, this reaction is reversible, so it can follow the reverse backward reaction also. So to avoid this, what to be done, that all the things we are going to discuss here. So in this part, the sulfur dioxide is oxidized to sulfur trioxide by atmospheric oxygen in presence of platinized asbestos or vanadium pentoxide as catalyst. Okay, so this process, as I told you, carried out at 595 degrees Celsius. So in the contact tower, there is an ion converter with iron pieces packed in with the catalyst. Means iron is not catalyst. Iron is a material which gives the support to the our catalyst, that is vanadium pentoxide or platinized asbestos. Then these gases, free from dust, free from arsenic oxide particles, are first passed through preheater. Okay, so this preheater, what does it? It heats. It is heated at about 300 degree Celsius. Okay, before they are admitted to contact tower. So what happens? I will show here you a diagram. So you can see how the process is starting. First, your sulfur dioxide from purifying unit and oxygen is entering in these pipes. So these pipes are moving the gas in upward direction, which comes out through this. Okay, so these vertical pipes, they are interlinked, whereas in between this area is a which is not in which is blocked. Means sulfur dioxide and oxygen can pass through these pipes only. Okay, this is a vacant area, empty space in that chamber. So these two gases are passed through this pipe to the converter, you can see here. Okay, and this tower converter contains the towers, which are as I told you, iron material which is packed with our catalyst. Okay, so here heat exchanger or converter, heat exchanger and converter, this combined assembly is there. So as the gases pass through the catalyst pipes, you can see here vanadium pentoxide or whatever, asbestos, platinized asbestos. So when the gases are pass through this pipe, sulfur dioxide is oxidized to sulfur trioxide. since this reaction is exothermic, means here you can see energy is released, the heat produced rises the temperature of gas reaching in the catalyst pipe above 450 degrees Celsius. Means you can see when this process, these gases are flowing through this, they enter here, here the reaction takes place. When the product SO3 is coming out, lot of energy is released. And in the most of the modern so therefore the temperature rises above 450 degrees Celsius. So nowadays what they do, to use this heat energy again and again, there are two converters they use. Okay, so first gases are first passed through one converter at 595 degrees Celsius, where the rate of oxidation is about 80%, means 80% conversion is done in the first converter. Then these gases which are coming out again pass through another converter. From this it comes through another converter, they are sent to another converter. In the second converter, the process is carried out at 450 degrees Celsius, and here there is a, you can say, complete or almost 100%, that is up to the 97% conversion is carried out. But the exchange of heat takes place between the incoming gases passing upward. See, these are the you can see here, incoming gases, they are at the higher temperature, sorry, they are at the low temperature. The gas is coming out here, lot of energy is released in the converter, so that these gases are heated, they are passed through these around these pipes. Okay, the empty space around these pipes. So what happens, these gases SO3, okay, gives its energy to the SO2, okay, that hits the incoming gases. So this continuous that means cycling of the energy, cyclization you can say. So here, due to exchange of gases, the rate the incoming gases get heated. The rate of flow of gases is so adjusted that the temperature of reacting gases in the pipe is maintained at 450. Means here every time this SO2 and O2 need not to be heated again and again using preheater. Directly the heat of the product, that is SO3, is given to the incoming gases by passing through the gases around the incoming gases. So there is only exchange of energy, there is no mixing here. Okay, and this SO3 and other unreacted gases are passed through this outlet to second converter, where it is, there is a 100% conversion. So you can understand this working in the contact process, contact converter, how sulfur dioxide reacts with oxygen to convert it to sulfur trioxide. So that is a very important step that you have to understand. Means sometimes they may ask the full question, or they may just ask the what is the process, how the process is brought about in contact converter. So now you must have understood. Now we'll move to the next step of the manufacture of sulfuric acid, and that is absorption unit. Means now your sulfur is converted to sulfur dioxide is converted to sulfur trioxide. Now the last step is sulfur trioxide is to be converted to sulfuric acid, and that is converted by using this reaction. When sulfur trioxide is treated with water, so that it will be converted to sulfuric acid. And here also you can say the dilution or hydration of sulfur trioxide form, which forms sulfuric acid, is a exothermic reaction which releases lot of amount of energy. So sulfur trioxide released from converter cannot be directly absorbed in water, because it results in formation of dense sulfuric acid fog due to exothermic reaction. Means here what happens actually, the SO3 gas and H2 are coming together to form sulfuric acid. But these sulfuric acid molecules, what they do, these sulfuric acid fog consist of, means surrounded by sulfuric acid, but inside there are molecules of sulfur trioxide and water, so they form the fog. Okay, so this fog further cannot be dissolved in water. Okay, so they cannot be hydrated, and which cannot convert this sulfur trioxide to sulfuric acid. So for that you have to use sulfuric acid, concentrated sulfuric acid. Means how it is, the process is carried out, that to avoid this formation of mist, you can say mist like this. You can see here outside there is a sulfuric acid form initially, then steam, water molecules and sulfur trioxide, they get trapped in this sulfuric acid molecule gathering, so they form the mist. This is the mist, this diagram. So to avoid, and this cannot be further hydrolyzed, or they are not is dissolved, they cannot be dissolved in water. So what is the role of concentrated sulfuric acid? To avoid this mist formation, the cooled gases from contact converter are passed up the absorption tower. Okay, where they meet descending stream of concentrated sulfuric acid. Now, if you remember that figure, from the top, sulfuric acid is spread over these gases, that is sulfur trioxide. So what happens here? When they come in contact with sulfuric acid, they form oleum. Okay, which is called as a mixture of sulfuric acid and sulfur trioxide. This oleum you can call it as a fuming sulfuric acid. Okay, and this fuming sulfuric acid can be easily dissolved in water, so that you can dilute it up to as per your requirement. So directly uh, contacting the sulfur trioxide with water is not helpful. You have to use concentrated sulfuric acid, which forms oleum, and this oleum helps to dissolve the sulfur trioxide in water to form H2SO4. Okay, uh, so this absorption rate is adjusted so that the 100% acid is formed at the bottom. Okay, means this amount of water cannot go beyond certain limit, so that you should not get a diluted sulfuric acid. So if you want to get 100% sulfuric acid, you have to adjust the flow of that sulfur trioxide in the this absorption unit, or you can say absorption tower. Okay, so this is all about the manufacture of second basic chemical, that is sulfuric acid. Now how to get maximum yield, you can say up to 100% yield, without any contamination, without any economical loss. How to bring about that can be discussed only by discussing physico-chemical process, that is, and we are going to discuss the physico-chemical process for contact process. Now in this contact process, we have seen that there are three steps, and out of three steps, the second step, conversion of sulfur dioxide to trioxide, is very tedious or very critical. So for our discussion, we are considering only this conversion uh, for our physico-chemical principle discussion. Okay, now here you can see easily that SO2 two times, oxygen one time, that is 2 volume of SO2, 1 volume of oxygen, convert to 2 volume of sulfur trioxide, and with evolution of 196 kilojoule per molecule energy. Means here two three things you can see. If you want to talk focus on volume, volume is decreasing. Means same discussion is here as that of your ammonia. Here volume is decreased, getting decreased in the product, so increase in pressure will favor the reaction. This reaction is exothermic, lot of energy is evolved, so decrease, or you can say reaction at low temperature will be favored That is the second thing. And third, we'll discuss separately what is the effect of catalyst, effect of concentration. Okay. Now this is a reversible reaction. So according to mass law equation, the equilibrium constant for this reaction is given by this equation, where you can see this reaction is reversible and the forward reaction is exothermic. This is a decrease in volume when sulfur dioxide is formed. Hence, according to Lee-Catelier principle, you can say that low temperature, high pressure, and increased concentration of sulfur dioxide and oxygen should favor the formation of sulfur trioxide. However, if you talk about only temperature, at low temperature, what happens? Though the reaction yield is favored, the rate of reaction becomes slow. So, hence, in practice, optimum temperature is kept. Okay, and the use of catalyst show the rise in rate of the reaction. So, for that, we'll discuss the effect of temperature. So this chart you can see here, if you carry out the experiment of this conversion at various temperature, you can see that as the temperature increases, the output or yield or the conversion of SO2 to SO3 decreases. So what you have to do, at 400 degrees Celsius the conversion is 100%, you can say, but the rate is very low. Or you in other way you can say like ammonia, here the equilibrium cannot be achieved. So the rate of reaction at 500 degrees Celsius becomes 40 times as fast as that of 400. Means again the rate increases if you increase the temperature. So at 400 degrees Celsius, at 550 degrees Celsius, it is fastest, you can say. But we have seen that increase in temperature decrease the yield. Means this is the dilemma. Low temperature does not help to attain the equilibrium. Means reversible reaction may start. Whereas high temperature will increase the forward reaction, but the yield will decrease. So to come out of this problem, we have to think about the use of catalyst. Okay, so this tricky situation is solved as follows. The reverse reaction does not take place appreciably below 550 degrees Celsius. Hence the conversion is carried out in two stages. One is 80% conversion is carried out in first stage, that we have seen in contact converter. We have to use two converting towers. In the first, there is 80% conversion, whereas in second there is a 99% conversion. For first tower, the temperature is kept at 595 degrees Celsius, whereas for second it is 450. So due to 550 degrees Celsius, the rate is higher, conversion rate, whereas due to in second tower, due to use of 450 degrees Celsius temperature, the conversion becomes 100%. So the optimum temperature range for this oxidation process is 450 to 550. So here, under physicochemical process, effect of temperature means rise in temperature does not help, but the process can be carried out over the range of temperature by using catalyst, so that in two steps, so that in first step there will be 80% conversion, whereas in second step there will be 100% conversion. Okay, so we'll stop for today's lecture here. We'll in the next lecture we'll discuss the effect of pressure, effect of concentration, effect of catalyst, then rest of the points from this manufacture of sulfuric acid. So we'll start the discussion, we'll continue the discussion in next lecture. For today's lecture we'll stop here. Thank you.